Hey everyone, welcome back to Daily Dose of Space. Today, we've got a genuinely surprising update, and honestly, one that feels like something straight out of a cosmic documentary. The comet C-2025K1, also known as Atlas, has split apart into 3 individual fragments after its close encounter with the Sun. This event wasn't predicted, and astronomers around the world are now trying to understand exactly what caused the breakup and what the pieces can tell us. And as if that wasn't enough, a completely separate research team has just published results showing that our entire solar system might be moving through the galaxy more than 3 times faster than we previously thought. 2 completely different discoveries, but both paint a picture of a solar system that's more dynamic and active than we typically imagine. Let's get into it. The comet breakup. C-2025K1 Atlas wasn't expected to be a dramatic object. It's one of many comets discovered by the Atlas survey, and for most of its journey inward, it behaved just like a standard long-period comet. But as it approached perihelion, the closest point to the Sun, astronomers noticed subtle irregularities in its brightness. At first, it looked like the usual increase caused by heating and outgassing. But then the pattern changed sharply, and several observatories captured something unusually striking. The nucleus had begun to stretch, deform, and eventually split into 3 distinct pieces. Newly released images, especially from the Asiago Observatory, show the breakup beautifully. 3 luminous fragments slowly drifting apart, each trailing its own faint tail. These visuals are calm and almost serene, but scientifically, they represent a violent internal process. When a comet breaks apart like this, it becomes a natural experiment, exposing the interior of an object that has been untouched since the formation of the solar system. Why comets break apart? Although comet breakups aren't unheard of, the underlying physics is always fascinating because it reveals the balance between sunlight, temperature, internal structure, and orbital motion. When a comet gets close to the Sun, the temperature difference between its sunlit and shaded sides can become extreme, sometimes hundreds of degrees. This creates internal mechanical stress that begins forming cracks throughout the nucleus. At the same time, the ices inside the comet begin to sublimate, which means they turn instantly from solid to gas. If those gases become trapped in pockets within the nucleus, the internal pressure rises until the structure can no longer contain it. This combination of heating, stress, and internal pressure can slowly destabilize the comet until it reaches a point where the nucleus simply can't hold itself together. And in the case of C-2025K1, that moment happened just after its close pass by the Sun. The breakup wasn't explosive in a dramatic sense, but the internal forces were strong enough to separate the comet into 3 independently drifting pieces. This process tells astronomers not just about the comet's exterior activity, but also about what lies beneath the crust, details that would normally stay hidden. Why this breakup is scientifically important. What makes this particular fragmentation especially interesting is the comet's unusual chemistry. C-2025K1 appears to be carbon-poor, which is incredibly rare. Most comets have abundant carbon-based molecules, yet this one shows a striking deficiency. That suggests it may have formed in a very cold or chemically isolated region of the early solar system, far from the typical carbon-rich zones. So, when the nucleus broke apart, it effectively opened a window into a type of comet we barely understand. Another important aspect is that fragmentation exposes fresh material that hasn't been altered by sunlight or space weather. Astronomers can now study reflectivity, composition, density, and gas emissions in a purer form. Breakups can even increase the brightness of a comet temporarily, since the freshly exposed ice sublimates more easily than the outer crust. This means the the fragments may remain visible for a while, and amateur astronomers might get a chance to see how they evolve over time. In short, instead of losing a comet, we may have gained an opportunity to learn more about a very rare one. What happens next? Right now, observatories worldwide are tracking how quickly the fragments are separating. The drifting speed can reveal the forces involved during the breakup and offer clues about the original nucleus's density and structure. Some fragments might gradually fade as they continue to disintegrate, while others may survive, follow their orbits, and potentially return in the distant future. In any case, astronomers already have enough data to gain insights that would have been impossible if the comet had stayed intact. And that brings us to today's second major story, a discovery that, at first glance, seems unrelated, but ultimately reflects the same idea. Our solar system is far more dynamic than we once believed. The solar system is moving faster than we thought. A new study suggests that our solar system is traveling through the galaxy at a speed significantly higher than older models predicted. Earlier calculations placed our motion at around 240 kilometers per second relative to the cosmic microwave background, but the new analysis estimates the speed at roughly 730 kilometers per second, more than 3 times greater. This doesn't affect life on Earth, but scientifically, it's important. The speed at which we travel through the galaxy influences how we interpret the cosmic microwave background radiation, which is one of the most crucial tools for studying the early universe. It also affects models of how galaxies interact, how the Milky Way moves, and how cosmic structures evolve over billions of years. If our solar system is moving faster than expected, that could suggest our neighborhood of space is shaped by stronger gravitational interactions or currents within the Milky Way than previously understood. At first, a comet breaking apart and the solar system's speed sound like unrelated events, but they reveal a shared truth. Space is not a calm, still environment. Everything is in motion. Comets evolve and fracture as they orbit. Stars migrate through the galaxy. Our own sun isn't stationary. It's traveling along a long, complex orbit influenced by the Milky Way's structure, dark matter, and gravitational interactions with neighboring systems. In a way, the breakup of C2025K1 is a small-scale reminder of the same forces shaping the larger galactic environment. The sun drags comets along its path through the galaxy, and differences in motion can alter comet orbits, shift reservoirs of icy bodies, and occasionally send objects inward toward the inner solar system. Both stories highlight how dynamic and ever-changing our cosmic environment really is. So that's today's Daily Dose of Space. A rare carbon-poor comet splits into 3 fragments, giving us a direct look into materials that predate the solar system. And at the same time, new research suggests our entire solar system is traveling through the galaxy far faster than older models estimated. 2 discoveries, completely different scales, but together, they show how alive and active space truly is. Thanks for watching, and if you enjoyed this video or learned something new, feel free to subscribe for more space news and deep dives. I'll see you tomorrow.